It has been 2 years since NASA's James Webb Telescope gave us a stunning first look at the depths of our universe. The $10 billion telescope is the largest and most powerful in space. It captured these images.
Yes, we expect James Webb to make great discoveries. We expect that.
Something strange happened in space, and the world was never told why. Humanity's most advanced eye on the cosmos, the James Webb Space Telescope, was built to peer into the earliest light of the universe, to glimpse galaxies born billions of years ago. But then, without warning, it was abruptly turned off. No technical failure, no public farewell, just silence. And the last place it looked before going dark wasn't a distant star cluster. It was Mercury, the closest planet to our Sun. Why would a brief glance at a scorched airless rock trigger an international blackout of data? What could possibly be hidden beneath a world bathed in solar fire and long considered geologically dead? And most unsettling of all, what if Webb didn't just observe something extraordinary, but woke it up? Above the turbulent blue world of Earth, one of the most sophisticated human creations ever assembled drifted silently in the cold expanse of space. The James Webb Space Telescope, born from decades of innovation and international collaboration, had spent its life capturing faint echoes from the beginning of time. Its purpose was simple in theory but ambitious in scope: to gaze into the depths of the universe and bring back light from the past. It did so with precision, elegance, and reverence, revealing nebulae, galaxies, and the unseen fabric of the cosmos. But everything changed the moment its sensors were directed inward, not outward, toward the sun-scorched face of Mercury. Mercury had always been a familiar puzzle to planetary scientists, a world that baked in brutal solar radiation during its long days and froze during its nights. Closest to the Sun, it had long been assumed too hostile to yield more than geological curiosity. Its peculiar orbit, dense iron core, and surprising magnetic field were already enough to intrigue geophysicists. But none had ever suggested Mercury was anything more than a lifeless, battered sphere of rock and metal. The James Webb Telescope was never designed to study planets so close to the Sun. Its advanced instruments were optimized for faint signals from ancient galaxies, far removed from the harsh glare of solar proximity. But during a calibration phase involving a rare reorientation of its optics, its gaze briefly turned toward Mercury. The stated reason was to test adaptive imaging techniques near intense light sources. In practice, this shift became a point of no return. Within that narrow window, something unexpected emerged. It wasn't just geological features or surface irregularities. What the telescope observed triggered a domino effect within agencies, institutions, and governments. Thermal patterns surfaced, patterns too symmetrical, too rhythmically sequenced to belong to random geological activity. Structures beneath the crust aligned in tri. They stretch for kilome, buried under layers of irradiated stone invisible to the naked eye but impossible to ignore under infrared scrutiny. More startling was the composition of these zones. Spectral analysis revealed materials and compounds never observed under Mercury's conditions. Some mirrored highly reflective alloys, crystalline lises, and engineered surfaces seen only in advanced earthbound laboratories. These weren't natural deposits formed under pressure or ancient lava tubes. They bore signs of intentional construction, layered, ordered, and concealed beneath the crust. Within hours of this revelation, something shifted within the corridors of power. Data that should have entered public archives was suddenly withheld. NASA issued a statement downplaying the Mercury observations, citing calibration stress and system strain. But this technical reasoning coincided too neatly with an internal scramble. Classified reviews began not by scientific councils, but by defense and intelligence organizations. Access to live feeds was restricted. Previously, open databases began stripping entries. Files once visible to university teams and research institutions became inaccessible overnight. Those involved with the Mercury imaging, engineers, analysts, and postdoctoral researchers were removed from their roles or silenced under administrative reshuffles. A few vanished from public rosters altogether. The act of pointing the world's most powerful telescope at Mercury had apparently crossed an unseen boundary. A quiet but resolute wall of silence descended. What could possibly provoke such an overreaction? Why would viewing a barren, sun-scorched planet trigger security lockdowns, military briefings, and wholesale data redactions? The answer, though buried in speculation, echoed among those with even a cursory familiarity with planetary systems. Perhaps Mercury was never just a planet. Perhaps it was something else entirely, something ancient, technological, and deliberately hidden. This hypothesis had circulated in obscure academic corners for decades. Mercury's odd rotation, its tightly locked orbit, and its unusually large metallic core had puzzled scientists for generations. The idea that these anomalies were artificial rather than natural had always been dismissed as fringe thinking. But now, with Webb's instruments uncovering symmetrical thermal emissions and trace materials with manufactured qualities, these old theories were resurrected with disturbing relevance. In the weeks following the telescope's sudden dormancy, planetary scientists around the world found themselves locked out of their own projects. Requests for observational time on inner planets were denied or redirected. Even allied space agencies, the European Space Agency, the Canadian Space Agency, were stonewalled. Some issued carefully worded public statements, but privately, confusion and discontent simmered. The telescope had always been a shared resource. Its unilateral shutdown came as a betrayal. Other astronomers, now sidelined, began to piece together the story from fragments. Archived data, orientation logs, orbital paths, they reconstructed what little remained from public sources before the curtain fell. One key discovery stood out. Webb had spent far more time focused on a specific region near Mercury's equator than officially disclosed. This area, once believed to be geologically inactive, was under renewed scrutiny. Archived readings from older missions like Mariner 10 and Messenger were revisited. Researchers noticed subtle magnetic disturbances in that same region, anomalies long written off as instrumentation glitches, but placed in the context of Webb's final observations, they took on new meaning. These disturbances were not random. They formed a pattern, a rhythm. At the same time, radio telescopes around the world began registering faint pulses emanating from the direction of Mercury. Low-frequency emissions, not easily dismissed as background noise, began to repeat at uneven but structured intervals. Amateur SETI enthusiasts and professional observatories alike noted them. While not definitively artificial, they didn't match any known natural process. Temperature mapping satellites also recorded minute but persistent thermal variances across Mercury's surface. These weren't linked to sun exposure or rotation. Instead, they clustered around the same regions identified in Webb's last pass. Slight increases in thermal output appeared during Mercury's terminator phase, the thin boundary between night and day. These subtle fluctuations suggested activation, response machinery perhaps stirring from long dormancy. The possibility that something dormant beneath Mercury's crust had responded to Webb's infrared scans chilled those who considered it seriously. Had the telescope done more than observe? Had it triggered a sequence, awakened a mechanism, or sent an unintentional signal? Within months, the vacuum left by Webb's silence became deafening. Scientists were left with nothing but conjecture and whispers. No new missions to Mercury were announced. No follow-up studies were green-lit. Webb's instruments remained in standby, and no firm date was given for reactivation. It was as if the eyes of humanity had been ordered shut. And still, questions swirled in the void. Was the shutdown a measure of caution or containment? Was it scientific discretion or strategic silencing? For many, the events surrounding Mercury had become less about astronomy and more about something deeper, something no one had prepared for. While the scientific community grappled with restricted access and mounting frustration, a separate network began piecing together the clues.